Now for sulfur trioxide, the formula is SO3. The sulfur is the central atom, and remember that each sulfur has 6 valence electrons, and each oxygen also has 6 valence electrons. And so the total number of valence electrons is going to be equal to, and we've got 4 atoms, each with 6, so it's going to be 24 valence electrons. And so the number of bonds that we're going to have to form is going to be then 8 times 4 minus the 24, the number of valence electrons, divided by 2. And this comes out to be then 4 bonds. And so now we got 4 bonds between 3 atoms, or sorry, between the 4 atoms. So we're going to draw this sulfur as our central atom, and we now have oxygen, and we're going to draw 1 bond to each oxygen. Now we need to add 1 more bond because remember we have 4 bonds to account for, so we're going to include a double bond here. So now we're going to start adding electrons so that each atom has its stable octet, and you'll note that we can't add any more to the sulfur because the sulfur has 2, 4, 6, 8 electrons and the 4 covalent bonds. So now what we have to do is add the rest of the electrons, and this and if we check our numbers here, we got 4 plus the 8 is 12, so we need to add another 12. So what we do is we add 6 around the other 2 oxygen, and you can't really tell that that's an electron, so I'll draw it a little bigger. So there we go. We've got 6 valence electrons around this. Now the thing you have to realize here is that this shared pair of electrons in this bond and in this bond, these two electrons in each case came from the sulfur, because remember that the original oxygen had 6 valence electrons, so that means that these are the original 6 valence electrons. So the bonded pair comes from the sulfur, and this is called a coordinate covalent bond, where one atom provides both of the shared electrons in the covalent bond. So these 2 bonds are coordinate covalent bonds. And the other thing that's a little special case here is that this double bond does not stay between this oxygen and this sulfur. It actually shifts around so that all of these bonds have a little double bond characteristic, and so these the bonds actually, the distance between the atoms is identical, and so that there is a constant shifting of the double bond, and this is called resonance. So as the double bond shifts around, that's called resonance, and so the this shared pair of electrons, the double bond, moves around and is not locked between the sulfur and one of the oxygens. So if we're going to consider what the shape of this is, we have this is going to be trigonal planar, and the reason it's trigonal planar is because we have 3 oxygen bonded to a central sulfur, and remember that there is no lone pair, there are no unbonded electrons around the central atom, which in this case is sulfur. So that means the shape of this atom is trigonal planar.